Good morning, students. Students, this lesson is of class 9th for the subject of physics, and we will be studying about chapter number 4, and today we will continue further with topic total internal reflection through a total reflecting prism. And this particular topic is given on page number 95 in chapter number 4, refraction of light at plane surfaces, in your physics textbook titled Concise Physics by Selena publication. And these notes and the interactive session is provided to you on 23rd November 2020. So now students, open page number 95 in front of you. So first of all, let us study the definition of total reflecting prism. A prism having an angle of 90 degrees between its two refracting surfaces and the other two angles each equal to 45 degrees is called a total reflecting prism. So students, if you have a prism in such a way that the angle between its two refracting surfaces is 90 degrees. As we have already discussed that in case of a prism, two sides are refracting while the third side, that is the base of the prism, is non-refracting. So the angle between the two refracting surfaces, if it is 90 degrees and the remaining two angles are equal, that is both are equal to 45 degrees, then such a prism is known as total refracting prism. So now the question arises, why it is named so? It is named as total reflecting prism because the light incident normally on any of its faces. There are three faces of prism. So if the light is incident normally on any of its phases, the light will suffer total internal reflection inside the prism. So it means that if the light is incident normally from your first side, your first surface of the prism, then again TIR will occur. While if it is coming from the second surface, normal incidence, again TIR will occur. And even if it is coming from the base, normally incident, then again the case of TIR will occur. So if the light comes from the first surface or second surface or the third surface of the prism, TIR will definitely occur in such cases. So students, it is named as total reflecting prism because the light incident normally on any of its faces suffers total internal reflection inside the prism. And because of this behavior, a total reflecting prism is used for three purposes. The first purpose is to deviate a ray light through 90°. Second purpose, to deviate a ray of light through 180°. And third purpose is to erect an inverted image without producing deviation in its path. So students, we will be studying the first two factors in detail with the ray diagram. So coming to the first diagram, that is to deviate a ray. Deviate means to change the path of the ray as compared to its incident direction. So to deviate a ray of light through 90°. So students, kindly observe figure number 1 drawn on page number 1 of the notes sent to you on 23rd November 2020. So students, in figure number 1, see the direction of incident rays and emergent rays. Student, first of all, see the ray denoted by symbol P. This ray is normally incident on the surface AB of the prism. Normal incidence means the light will move inside the prism without getting deviated. First of all, let us complete the angles here. If angle on normal is made 90°, so the angle of prism A is 45°, while the angle made by the upper triangle in case of figure 1. Upper triangle means triangle A, M and X. So the angles you can see marked in figure number 1. Normal incidence means the light is having 90°, while angle A is 45° because it is total reflecting prism. So the third angle will be automatically 45° because sum of all the angles, all the interior angles of a triangle is 180°. So students, at point X, draw a normal as shown in figure in a dotted manner. So let us complete the angles. So you can see that when the light is moving from M to X, the angle of incidence is 45°, while critical angle of glass is always 42°. So students, at point X, the light has to go from denser to rarer medium, while angle of incidence is 45°, which is greater than critical angle. Then what will happen? As studied on 17th November 2020, the light will not move in the second medium. Rather, a case of TIR occurs at point X and the light gets reflected in the same medium such that angle of reflection will also be equal to angle of incidence. So angle of reflection will be 45°. And the light will pass from point U such that if the angles on interior of X is 45°, on the extreme right side downward, if it is 45°, angle C is also 45°. So students, see triangle X, U and C. If the angle made at X is 45° in this triangle and Angle C is also 45 degree. That means angle made at U is 90 degree. So 90 degree means the light is normally incident at point U, and thus angle of incidence here will be 0 degree, which is less than 42 degree. So TIR will not occur at point U. Rather, the light will move undeviated in other medium. Which process is occurring at U? Refraction. Students, at point X, TIR is occurring, but at point U, no TIR is occurring. Rather, refraction is occurring at that place. So students, see how much the P ray is deviated. If you see P to X and then X to U, how much is the angle here? 45 plus 45, that is 90 degree. So we can say that the light has deviated through an angle of 90 degree. As we have done the ray P, in the same manner, one more ray has been drawn in the similar fashion, such that Q is incident at Y and TIR is occurring at point Y, and the ray is getting deviated in the same manner from point V, and again the angle of deviation is 90 degree. So students, the rays are getting totally internally reflected from points X and Y on the surface AC of the right angled isosceles prism. Why isosceles? Because the two angles in this prism is equal to 45 degree. So the two light rays are finally emerging out from points U and V on the surface CB of the prism. So students, such case is basically used in periscope. This action of prism is used in periscope. Otherwise, in case of periscope, we are usually using mirrors, plane mirror. But instead of plane mirror, if we use periscope, the image formed is more better. In case of plane mirror, if the light reflects, there is certain loss in energy. But in case of total internal reflection, there is no loss in energy. So the image formed in the emerging ray is very bright. Therefore, we prefer periscope to be made by prism using the condition as shown in figure number 1. So students, if the light rays were incident from CB surface, right now we have made light incident from AB surface. I am saying that if the light is coming from surface CB, that means if the light was going from U, then it would have followed the same path. That is, from U to X, it would have struck the prism at point X and would have emerged out from point M. Only the arrows would have changed. The rest of the angles and the remaining things were same. So we can say that if the light rays were incident from CB surface of prism, they would have retraced same path and the rays would have emerged out from the surface AB of the prism. So students, in figure number 1, the incident ray was actually deviated by an angle of 90 degree even if you go from CB to AB or from AB to CB. Now let us continue with our second ray diagram. And here we have to deviate a ray of light through 180 degree. Now students, observe figure number 2. Here I have taken an object, placed horizontally such that the arrowhead is pointing towards the number 1 I have written. Students, this first ray, now let us see one by one all the rays. The first ray is normal incident on the surface AC. It passes undeviated and touches the point X on surface BA of the prism. Now, if this angle is normally incidence, that means if this is 90 degree, angle A is 45 degree, then angle of incidence at point X will be 45 degree, which is greater than critical angle. Thus, the ray will bend inside the same medium. That means what is happening at point X? At point X, the condition of TIR is occurring. Now the light has totally deviated by 90 degree. And this ray number 1 is now further moving towards the CB surface of the prism, such that it is again incident at point Y. And if we draw a normal from point Y, we will see that the angles made at point Y, angle of incidence is again 45 degree, which is greater than critical angle. Now what will happen? The ray will again get totally internally reflected, such that the angle of deviation is 90 degree. So this ray 1 is actually deviated by how much angle? 90 plus 90, that is 180 degree. Similarly, the ray 2 has been shown in the diagram, going from one surface to point L, getting totally internal reflected, and then again total internal reflection at point M is occurring. So what is happening? If the object is formed, if the object is placed, and see the arrowhead of the object, and see the first ray, wherever the first ray is coming out, that will be the place of arrow in image. So see, the object and image are placed at an angle of 180 degree. They are anti-parallel to each other. So students, listen. Students, use of such prism, this action of prism is used in binocular and camera to invert the image. If you want to make the image upside down, to invert the image without any loss of intensity or brightness, then we will use the prism in such a case as shown in figure number 2. You can invert the image with respect to the object. Now students, let us do some questions based on TIR. So the first question for today is the critical angle for material of which the equiangular prism ABC is made is 60 degree. So what is given here? That critical angle is 60 degree. Students, equiangular. Now the word equi means equal. Angular means angles. So if all the angles of triangle is equal, that means the triangle having all angles A, B and C are equal. It means that it is an equilateral triangle only, because all the angles x plus x plus x is equal to 180. 3x is 180. That means x is 60 degree. So each angle is 60 degree, equal angular prism. And the critical angle is also given to be 60 degree in this case. And further, it is said that a ray of light incident on the side AB of prism is refracted along DE such that the angle it makes with the side AC is 150 degree and EDB angle is 90 degree. So the question is to draw the path of the incident ray and also what is the emergent ray and also the path along which the ray DE travels from point E onwards. Now see diagram, figure number 3, students. Here all the angles A, B and C are equal. It's an equilateral or equiangular prism. It is given that the light is incident at point D and it is normally incident. Normally incident means the light will move further undeviated. Without changing its direction, the light will go from air to the glass medium of the prism and it will strike the surface AC at point E. Angle D, E and C is given to be 150 degree, and if we draw a normal at point E, let us draw a normal at point E. Normal means the angle between normal C and E is 90 degree. Then students see in that case angle DE and normal is 60 degree. Now what is angle of incidence for light falling at point E? Students see angle of incidence is angle between incident ray and the normal, which is now 60 degree. So angle of incidence is 60 degree and critical angle is also given to be 60 degree. If angle of incidence is equal to critical angle, in that case, the light gets refracted on the surface only such that angle of refraction will be 90 degree. So students, observe figure number 3. The ray DE makes angle 150 with the side AC. So at point E, the light is traveling. What is happening at point E? The light is traveling from denser to rarer medium, and angle of incidence is equal to critical angle. Thus, TIR will not occur. The light ray is refracted at 90 degree along EC. Now the second question is, what is meant by the statement the critical angle for diamond is 24 degree? Student, it means that when a ray of light passes through diamond, that is denser medium, to a rarer medium at angle of incidence 24 degree, then the angle of refraction in the rarer medium will be 90 degree. Coming to the third question, If two incident rays are as shown in figure number 4, the two rays have been shown in figure 4, ray A, ray B. And if critical angle is 48 degree for water air surface, then you have to complete the ray diagram, which is shown in figure number 4, and show the refracted rays for both A and B. Now students, the answer to this figure 4 can be, now A was normally incident. Normal incidence means the light will move undeviated in the other medium. So the light will move in a straight way. Here at point A, in case of normal incidence, angle of incidence is 0 degree. Therefore, angle of refraction is also 0 degree. This is the case of normal incidence. While C, what happens to ray incident at point B? So the ray is making angle 48 degree as given in question. And this angle of incidence, that is 48 degree, is equal to the given critical angle in the question. So if angle of incidence is equal to critical angle, the refracted ray comes on the surface of or boundary of water and air, and the angle of refraction is 90 degree. So students, with this, I am ending this interactive session for today, and we have come to the end of chapter 4. You all are requested to go through entire chapter number 4 and kindly practice the ray diagrams and also learn the difference between TIR and reflection from a plane mirror, which is given on page number 98 of your physics textbook. Thank you, students.